Here's a document. A few pages of prose describing an order management system, customers, products, orders, a payment that arrives from somewhere else. And here's what you're asked to deliver: a real, running service. Correct, secure, tested. The distance between those two things, a spec and working software, is the entire job. This series crosses that distance for real. We take one written spec and build the whole service from it, piece by piece. And in the finale, we hand the exact same spec to an AI and ask, can it cross the distance too? It starts with a skill nobody teaches you: how to read a spec. The mistake is to read a spec like a to-do list, start at the top, and type. A spec isn't instructions, it's a description of a world, and you have to reconstruct that world in your head first. So you read it more than once, each time for a different thing. Once for the nouns, the vocabulary of the domain. Once for the rules, the invariants that must always hold. Once for the verbs, the operations. And once for the edges, what's inside your service versus what's external. And you read it skeptically, because a spec is written by a human, or lately by an AI, and it will have gaps and contradictions. Your job isn't to obey it. It's to understand it well enough to catch where it's wrong. Start with the nouns. In our spec, the important ones are right there in a glossary: customer, product, order, line item, actor, payment. Each of those becomes a name type in the code. And here's the discipline. You keep the exact words. If the spec says line item, your code has a line item, not an order row, not a generic item, not a thing. That sounds trivial. It isn't. When the words in the document match the words in the code, everyone, the author, the reviewer, the next engineer, the AI, is talking about the same concept. Eric Evans called this the ubiquitous language, a single shared vocabulary that runs from the spec straight through to the running system. Naming drift is where misunderstanding and bugs get in. Second pass, the rules. Go through and circle every must, every unique, every only if, every between X and Y. Those words are invariants, conditions that must hold no matter what the caller does. In our spec, a SKU must be 3 to 20 uppercase characters and unique. An order can only be approved once its payment is confirmed. Stock can never go negative. Each of those is a guard you'll enforce in the domain. Then the third pass, the verbs: create an order, add a line item, submit, approve, ship. Those become your operations, your commands and queries. And the endpoints in the spec become your API surface. You haven't written any code, but you already see the shape of the whole service: its types, its rules, its verbs. Here's the actual spec. Notice the shape. Section 2 is a glossary, the ubiquitous language, handed to you: customer, order, line item. Those are your types, already named. And Section 3 describes each aggregate with its rules as plain sentences. A SKU is 3 to 20 uppercase characters, unique, and read carefully. Lowercase input is rejected, not quietly fixed. A unit price is money, greater than 0, at most 2 decimal places. Every one of those clauses is a decision you'd otherwise have to invent and defend in a code review. The spec made them for you. Your job is to translate each sentence into something the compiler will enforce, and to notice if any sentence is wrong. And here's the translation in the real code. One sentence from the spec, 3 to 20 characters, uppercase letters and digits only, becomes one value object. The length rule is an attribute. The uppercase rule is a regex in a validation hook. There is no way to construct a SKU that breaks either rule. The only way to make one is through a factory that returns a result, a valid SKU, or an error. So a lowercase SKU can't slip through a code review, because it can't exist as a value in the first place. That's the move this whole series is about. Take each sentence in the spec and turn it into a type the compiler enforces. The spec stops being a document you hope everyone read, and becomes a shape the code can't violate. So that's how you start, not by typing, but by reading for the nouns, the rules, the verbs, the edges, and reading skeptically, ready to find the spec's mistakes. Next episode, we take the vocabulary we just extracted and turn it into the model, the aggregates, the value objects, and a state machine that makes an order's lifecycle impossible to get wrong. One spec, one service, built for real, and at the end, a machine that tries to build it too. Subscribe, and I'll see you in episode 2.